Hi class, so we've finished with fixed end moment, no? So somewhat I decided to discuss fixed end moment to you on a separate video, no? Kasi our next set of topics will somewhat involve solving for fixed end moment, no? So yung mga nauna nating topic before the fixed end moment, no? In determining the reaction of statically indeterminate structures, no, are somewhat called force method, no? So force method siya kasi, no, somewhat uh, we we try to solve uh, the force first, no, and then uh, try to uh, make an additional uh, so in other words, no, so we are trying to uh, solve forces, no, and then nag-i-involve lang tayo ng deformation or deflection for somewhat deformation or deflection or rotation, no, as a compatibility equation, no, or yung tinatawag nating additional na equation or additional information to solve it. Pero the next set of topics na i-discuss ko, no, are what we call displacement method, no, kasi we are now more on solving for displacement, no, and then uh, secondary na lang yung paggamit ng uh, equilibrium equation, no? So in the first type ng displacement method natin, no, is called the slope deflection method. Okay? So let me show you first what are or how do we do slope deflection method. Okay, so slope deflection method, no, is a displacement method of analysis introduced by George A. Maney in 1915, which relates to the moment at the ends of a member, no, to the rotations and displacement of its ends and the external loads applied to to the member, no. So let's try to consider, no, a member, no, a structural member AB of length L, no, with a concentrated load P, no. So itong concentrated load na to, no, it's just a representation of any type of loading, no, para for easier illustration, no. So kumuha tayo ng point ng segment AB, no, na length L, and then assume na when subjected to type of load, no, it will deflect, no, on this manner. Okay? And then you have now, no, so pagka hiniwalay, we try to separate segment AB, no, and we know na at the beam meron tayong moment, no, meron tayong bending moment at point A, no, and also at point B, no. So yung moment sa A natin, no, let's call this M sub AB, no. So M sub AB kasi point A going to point B. And then let's call yung moment at point B na M sub BA, no? So B going to A, no? Let's say also that the distance P, no, is small a from capital A, no? And then yung point also small b from point capital B, no? So i-drawing natin ulit yung elastic curve niya, no? So let's say this is your segment AB, no, na this horizontal line, no, is the level, no? So, yung level niya, no, that is undeformed position, no? And then when we subject it to its respective load, no, ganito na yung itsura niya, no, upon deflection, no? So let's say also na ang final position niya, no, meron siyang final position, and then ang relative displacement ng point A sa point B is delta, no? So that is relative translation between two ends of the member, or let's say two supports, no? Kasi ang goal natin is to find the support reaction, no? So also, no, ang ano natin, ang ang beam natin, no, dahil sa load P na yan, no, it was also it naging subject din siya, no, into rotation, no? So meron tayong rotation theta A, no? So that is the slope at A, no? And then theta B, slope at B, no? Yung slope naman na dahil sa translation natin, we are going to call it psi, no? Greek symbol psi. Okay? And ang sa natin, no, is equal to delta over the length, no? So also let us assume, no, na let us also assume na we have this kind of moment diagram, no? We just try to by parts, no? So this is the moment diagram due to M sub AB, no? Yung triangle sa ilalim, and then yung dahil sa moment at BA, no? Let's say that is your M sub BA. And then we also have yung dahil sa external load, no? This one, no? Let's call this moment diagram 1, moment diagram 2, and then moment diagram 3. Okay? No? So we try to separate also, no? So para mas madali din, no? We are going to separate each load, no? So unahin natin yung i-subject ang beam into the moment M sub AB. Pag sinubject natin siya into M sub AB, no? Magkakaroon tayo ng rotation na theta A1 and then theta B1. Okay? So, ang amount of rotation, ang theta A1 natin, no? O nga pala, using area moment method, no? So, we have the tangential deviation of A with respect to B, no? Kapag ang tangent natin galing sa B. We have tangential deviation of B with respect to A pag ang tangent natin galing sa A papunta sa B. Okay? And ang ginawa ko lang dito, pinag-iwalay ko yung moment diagram niya, no? So kasi instead of hanapin natin siya ng magkakasama in order to not make it confusing, no? So una kung i-subject yung beam natin into moment AB, no? And we have theta A1 and theta B1. Okay? Ang tangential deviation natin, no? So I will not manually compute it anymore for you, no? So you can try to do it yourself, no? So we are nakuha natin na ang tangential deviation of B with respect to A is equal to M A sub B L squared over 3EI. No? So that is when I use the area moment method, and then this one, M sub AB L squared over 6EI. No, yung tangential deviation of A with respect to B. No? So ngayon, isa-subject naman natin yung tanggalin natin yung M sub AB, no? Ipapalit natin yung M sub BA. Pag nilagay natin yung M sub BA, no, we're going to have slope, no, theta A2 and theta B2. Okay? No? So, derived formula again, no? Ang tangential deviation of A with respect to B naman natin, M sub BA L squared over 3EI. And then, yung tangential deviation of B with respect to A is MBA L squared over 6EI. Okay? So ngayon, tanggalin natin yung M sub BA, ipapalit naman natin yung external load niya. Then these are the derived formula for the tangential deviation. No? So PA over 6EI times L squared minus A squared, yung tangential deviation of A with respect to B, and then tangential deviation of B with respect to A is equal to PB over 6EI times L squared minus B squared. Okay? No? So before that, no, let's try to determine the relationship first of our tangential deviation and from our slope. No? So this is using the original area moment method. No? So meron tayong from the elastic curve, no? Ang tangential deviation of A natin, ang ating theta A, no, is equal to tangential deviation of B with respect to A plus delta, no? So that is ito 'yan, no. No, so ito yung elastic curve natin. Kukuha tayo ng tangent from A, no? And then ito yung tangential deviation natin. Kasi ito na yung bagong point B natin eh. So this is the tangential deviation of B with respect to A and delta, no? So over L. Okay? Theta B naman is equal to tangential deviation of A with respect to B plus the delta over the length. No? So we are able to derive, no, theta A minus psi is equal to tangential deviation of B with respect to A over the length. No? And theta B minus psi is equal to tangential deviation of A with respect to B over the length. No? So, itong relationship na to, no, is regardless of design convention, no? So hindi yung nakuha natin to from a simple ratio in proportion only. So sign convention will not be considered, no, when doing these relationships, no? Okay? So let's substitute all, no, lahat ng tangential deviation na nakuha natin, no, on this equation, no? So let's call this the asterisk. Okay, no? So substituting it, no, we have now your tangential deviation of A with respect to B, no, is equal to negative M sub AB L squared over 6EI, no, plus MBA L squared over 3EI plus PA over 6EI times L squared minus A squared. Sabi ko nga, no, do sa relationship between the tangential deviation and the slope, no, it is regardless of design convention. So we are just going to get the absolute value of this. No, so assuming that it's just a positive integer. No, so tangential deviation of B with respect to A, no, is equal to negative M sub AB L squared over 3EI plus M sub BA L squared over 6EI plus PB over 6EI times L squared minus B squared. Okay? And then substituting it doon sa nakuha natin, no, theta B minus psi is equal to 1 over L, no, this one, MAB L squared 6EI, no, minus M sub BA, L squared over 3EI, minus BA over 6EI times L squared minus A squared. No, so, for much easier simplification later, I decided to factor this out, no, naging L plus A times L minus A. And ang L minus A natin is also equal to B. No, so, no, ilalagay na natin siya dito mamaya. Theta A minus psi is equal to 1 over L times negative M sub AB L squared over 3EI, no, plus M sub BA L squared over 6EI plus PB over 6EI times L squared minus B squared. I also factor this out, no? L plus B times L minus B. Ang L na minus B natin is also equal to A. No? 6EI over L, no? Times theta B minus psi. No? So, ang ginawa ko din pala dito, no, I decided to multiply each sides by 6EI over L, no? In order for this to be cancelled out. No? So, para mailipat natin sa kabila kasi we need yung M sub AB and M sub BA. Okay? Is equal to MAB minus 2MBA minus PAB over L squared times L plus A. This one, 6EI over L times theta A minus psi is equal to negative 2M sub AB plus M sub BA plus PAB over L squared times L plus B. No? So we do the process of elimination. We multiply this by 2, no? Is equal to 6EI over L times 2 times theta A minus psi plus 6EI over L times theta B minus psi is equal to negative 3M sub AB plus AB over L squared, PAB over L squared times 2L plus 2B minus L minus A. Then we have 6EI over L times theta B plus 2 theta A minus 3 psi is equal to negative 3 MAB plus 3 PAB squared over L squared. No, so we transfer this to the other side. No, we have now, no, M sub AB so to negative 2EI over L, no, times theta B plus 2 theta A minus 3 psi, no, plus PAB squared over L squared. No? So, we are able to find out na ang PAB squared over L squared, no, is the negative fixed end moment of AB. No? So, that is, no, negative PAB squared over L squared. No? MAB kasi with respect to the left, that is counterclockwise. No? So, negative siya. Equilibrium wise, no? Next, we substitute yung na-solve natin. Use the original value for MAB, no? 6EI over L times theta B minus psi is equal to negative 2MBA minus 2EI over L times theta B plus 2 theta A minus 3 psi plus PAB squared over L squared minus PAB over L squared times L plus A. Okay. And then we simplify it again. Now 6EI over L times theta B minus psi plus 2EI over L plus theta B plus 2 theta A minus 3 psi is equal to negative 2 MBA plus PAB over L squared times B minus L minus A. No? So ang B minus L natin is negative A. No? So that will become negative 2A. No? So all the 2 will be cancelled. Now we have now MBA is equal to negative 2EI over L times theta A plus 2 theta B minus 3 plus P A squared B over L squared. So yung FEMBA natin, no, is also equal to PAB A squared B over L squared. No? So Ang ano nga pala dito, yung moment BA at saka moment AB natin, no, are bending moments, no? So expect that the sign convention, no, yung sign convention natin dito, no, ay depende kung ano ang ginagawa ng moment mo sa beam. No? Is it making the beam smile or is it making the beam frown? No? So, pinapangiti ba yung beam or pinapasimangot? No? So, from here, no, we found out na PA squared B over L squared, no, like what I said, no, is the fixed end moment for BA. No? Okay. No? So, ayun, no? We form a general formula, no? M sub NF is equal to FEM NF plus 2EI over L times theta F plus 2 theta N minus 3 psi. Ang ibig sabihin ng N, yung near point, and then yung F, yung far point. No? So, this is the general formula, no, na you can just try to memorize, no? So in order to illustrate you further, let's try to solve a problem, no? Pero nga pala, no? So itong m sub n, itong general formula natin for slope deflection, no, is the main ingredient, no, somewhat ingredient, no, in solving the moment. Pero later on, we can try to manipulate, no, yung equilibrium equations, no, para mas kumbaga yung finishing touch na niya. Okay, so let's try to solve some problems, no? So let's apply, no, the principles of slope deflection method, no, to continuous beams, no. So you're given here a continuous beam, no, with fixed support at A, no, internal support at B, and simple support, no, or a roller at C, no. So both span AB and span BC are 8 meters, subjected to 25 kilonewton per meter, uniformly distributed load, no. So ang principle diyan, no, if we separate the span AB, no, so span AB, we're going to have a moment MAB, no, this will become your MAB, no, and then we're also going to have MBA, no, with respect to the span, no. So at the same time, no, so we are going to have M moment MBC, no, and then we're going to also have MCB. Okay? Pero, no, of course, speaking of with respect to the equilibrium, we know na wala tayong moment at point C. So therefore, yung MCB natin will become 0. Okay? No? So with respect to the support at B, no? Pag nilipat natin yung, let's say, yung counterclockwise na moment MBA doon sa right, no? So yung yung span B natin, a very small distance to the support, no? Lilipat natin yung MBA, no? That will be the opposite direction of MBA na nandun sa span, no? So we have MBA here. And then yung MBC natin, no? Counterclockwise na, assume na counterclockwise. These are just all assumed directions lang, no? So yung inassume natin counterclockwise na MBC, no, will become clockwise with respect to the support, no? So another equilibrium equation natin is MBA plus MBC is equal to 0. Next, dahil fixed support ang point A natin, no, we know that yung M sub AB natin is also equal to your moment at A. Okay? So now we play now with our slope deflection equations, no? So MAB, ang formula natin, MAB is equal to FEMAB plus 2EI over L multiplied by theta B plus 2 theta A minus 3 psi. MBA is equal to FEMBA is equal plus 2EI over L times theta A plus 2 theta B minus 3 psi. MBC is equal to FEMBC plus 2EI over L times theta C plus 2 theta B minus 3 psi. Then MCB is equal to FEMCB plus 2EI over L times theta B plus 2 theta C minus 3 psi. No? So wala tayong psi because we assume that all supports are on the same level even after subjecting the beam into with the load, no, with the uniformly distributed load. Kahit ilagay natin yung uniformly distributed load natin na all the supports are on the same level. No? So wala rin tayong theta A dahil fixed support yan, wala tayong relative rotation at point A. So theta A will become 0. Theta A is equal to 0, theta A is also equal to 0. Okay? So now, no, we determine now our fixed end moment. FEMAB is just the same as FEMBA, FEMBC, and FEMCB is equal to 25 WL squared over 12. No? So yung formula natin for fixed end moment are written on the table that I have provided, no, for you. Okay? And that is equal to negative 25 times 8 squared over 12. No, is equal to negative 400 over 3. O nga pala, the sign convention for our fixed end moment, no, will depend kung clockwise ba siya or counterclockwise, no? Equilibrium sign convention ang masusunod diyan. Okay? No? So therefore, sa point AB, no, that is negative 400 over 3 plus 2EI over 8 times theta B. No, MBA naman, 400 over 3 plus 2EI over 8 times 2 theta B. Okay, MBC, negative, no? So, negative tayo sa kaliwa. Yung mga kaliwang span natin, negative. Yung mga kanan, positive. Negative 400 over 3 plus 2EI over 8 times theta C plus 2 theta B. MCB, no, which is also equal to 0, is equal to positive 400 over 3 plus 2EI over 8 times theta B plus 2 theta C. Okay? MBA plus MBC is equal to 0. Then it is also equal to negative 2 times 400 over 3. No? So, pagsasamahin natin yung MBA at MBC natin, negative 2 times 400 over 3, no? 400 over 3 na galing sa BA. No? So, negative 400 over 3 plus minus 400 over 3. That will become 0. Plus 2EI over 8, no? So, times theta C plus 4 theta B is equal to 0. MCB natin is equal to 0, positive 400 over 3 plus 2EI over 8 times theta C plus 2 theta B is equal to 0. We simplify both of them. Now we're going to have EI theta C plus 4 theta B is equal to 0, equation 1. Equation 2, no? 2 theta C plus theta B is equal to negative 400 over 3. No, 4. ang EI theta C natin, no? So in terms of EI theta C na tayo rather than theta C only kasi divide lang natin siya ng EI, no? So EI theta C and EI theta B, no? Using you can try to use the process of elimination, no? How to solve systems of equation, no? So that is equal to negative 6,400 over 21 kilonewton meter squared. EI theta B is equal to 1,600 over 21 kilonewton meters squared. No, so ang negative dyan indicates that, of course, technically speaking, no, yung slope natin, pag ano, no, so, or let's say just clockwise siya. Pero mas madali nating matatandaan yung sign convention kung ang susundin natin yung slope na nasa mat, no? So yung going to the yung titignan nyo yung nandun sa yung upper na point ng linya, no? So pag nasa kaliwa yung upper point, no, that is negative, no? And pagka yung nasa kanan yung upper point, positive. Okay, substituting EI theta C and EI theta B, no, we have MA, no, is equal to M sub AB is equal to negative 800 over 7 or 114.28 kilonewton meter. No, so ang titignan natin dito if pinapangiti ba niya yung beam or pinapasimangot, no, yung sa AB. MCB is equal to 0. Okay? MBC natin is equal to negative 1,200 over 7, which is equal to negative 171.43. MBA is equal to 1,200 over 7, or 171.43. Okay? No, so, we now have our end moments. No? So, we can now solve for the reaction. No? So, yung mga na-solve nating moment kanina, ganito na yung convention niya. No? So, MAB natin is negative. No? So, relatively, napasimangot niya yung beam mo. So, ganyan yan. Then, dun sa span, no? Negative yung MBA natin. So, MBA natin, no, is 171.3. Okay? So, 171.43. No, so 171.43. Okay? No, so ano yung masusunod niyang okay, so let me correct myself, no? So ang sign convention natin for dito rather than kung pinapasangot ba or pinapangiti yung beam, no? We look dahil we use equilibrium equation here, no? So ginamitan na natin siya ng equilibrium dito. No? Sinubstitute na natin, no? So yung mga nakuha nating moment here, no, are, no, yung mga nakuha nating moment dito, no, are from equilibrium. So dito, no, negative 114.28 siya ay counterclockwise. Okay? And then yung nakuha natin sa MBC, that is negative 171.43, that is also counterclockwise, no, relative to the member. Okay? So MBA naman, positive 171.43 kilonewton meter. No? That is positive relative to the member. No? Relative to the joint naman, so ang ginagawa niya, that is relative to the joint, syempre yung kabaligtaran. No? That is this one. No? Also 171.43. Pag relative to the joint, no, so ang mangyayari, no, that is negative. No, so let me correct myself, no, for about it, no, for the sign convention. Okay, so ang gagawin natin, no? We have a 114.28 moment here. 107 na counterclockwise, meron tayong 171.43 na clockwise. So kapag pinagsama mo yung dalawang moment, we have, no, 114.28 minus 171.43, no? So, or rather, yung kabaliktaran, 171.43 minus 114.28, no? Meron tayong lalabas na 57.15 na ang mananaig clockwise, no? So 57.15 na clockwise, no? If we divide it by the length, which is equal to 8, no? Meron tayong 7.4, no? 7.08, no? Kilonewton, no? Pero ang direction niya magkaiba, no? So dahil clockwise yung resulting moment natin, pag pinagsama yung dalawang to, dapat magiging direction ng mga reaction natin counterclockwise. So kapag dito sa kanan, para maging counterclockwise siya, no? Of course, the reaction at A should be downward, no? So that is 7.08, no? So kabaligtaran naman, para counterclockwise, no? Siya ay 7.08. Oh, so dahil pataas yung 7.08 natin dito, pababa naman dun sa kabila. Okay? No? So dito naman 171.43, isa lang naman yung moment na nag-a-act dyan. No? So we get yung divided by the length, 171.43 divided by 8. No? So that is equal to 21.43. No? So 21.43. Pero ano ang direction? Dahil counterclockwise yung resulting moment natin, we need clockwise moment here. So para maging clockwise, downward ang reaction sa point C. Upward naman sa point B. No? So dahil upward tayo sa with respect to the member, with respect to the joint, downward siya. Pagsasamahin lang natin, no, 21.43 tsaka 7.08 will result to 28.51. Okay? No? So next, no, tanggalin natin yung mga end moment. We remove all the end moment, no? So we assume that they are all simply supported. No? So 25 times 8, no, divided by 2, 100, 100, 100, 100. So the reaction on the middle is equal to 200. If we combine the loads, if we combine all the reactions, ito na yung lalabas, no? That is equilibrium shortcut. Instead of using manually the summation of forces X, summation of forces Y, and summation of moment, we just use this one, no? Somewhat analytical, no? Okay, no? So again, no? So let's again dito sa dito sa MAB, MCB, no? With respect to the equilibrium, dahil ginamitan natin siya ng equilibrium, no? So ang lalabas na sign convention niya is also in equilibrium. Okay, another thing, no? So some final notes. Okay? Some final notes, no? So slope deflection method, no? To determine the moment, no, we try first to remove all the degrees of freedom. Ano yung sinasabing degrees of freedom? Yun yung the ability of the point being considered to be subjected to any translation or rotation. So meaning, tatanggalin natin lahat ng tendency niya para mag-rotate. No? So ibig sabihin, everything is strain. So ang lalabas doon, that is the fixed end moment. Pero of course, iisa-isahin nating tanggalin yung mga restraint niya. So sa inyo dito. No? So here, kung ginawa natin nung una, we assume that this is just fixed, no? We also assume that this is also fixed. Assume that this is fixed. So, ang mga moment dyan, moment here, moment AB, moment BA, moment BC, moment CB. No? Those are the fixed end moments. No? So, if we decided to release the restraints, no? I-release natin yung mga clamp, no? So, syempre, magkakaroon na siya ng slope. Okay? That is the principle of slope deflection method. No? So, from the formula. No? They are somewhat dependent on the stiffness. No? Okay? O nga pala, no? So let me correct myself again, no? I want to keep on emphasizing it to you para somewhat hindi kayo malito, no? Kapag ka nag-solve tayo, no? We when we're able to solve for slope deflection equations, no? Let's say dito M sub AB and M sub BA, and may sign convention na lumabas, no? So remember na with respect to the member, no, we follow the equilibrium sign convention, no? So ang madalas kong ginagawa, no, that is the clockwise positive sign convention, no? Clockwise positive, counterclockwise negative, no? So it's somewhat different again, no? So usually it is iba pa yung sign convention natin for bending moment, no? Ah, yung sinusunod nating sign convention for bending moment usually pagka nasa support na tayo with respect to the certain point na. So let's say dito sa point A, no, meron tayong maliit na distance going to from the left of A and from the right of A, let's say this one, no. Meron tayong moment na clockwise and then meron tayong moment na counterclockwise. So anong ginagawa niya, no? So somewhat it's making the beam smile, no? That is positive. No? So iba pa kapag point oriented or yung tinatawag nating joint oriented, no? But this is member oriented, no? And somewhat it follows the rule of the equilibrium, no? So we follow the sign convention when we solve for M sub AB or M sub BA or any letter, no? So kapag gumagamit tayo ng slope deflection equation, no? So kindly review, no, yung dito, no? So from our example a while ago, no? So yung this one, no? Negative, no? Negative yung M sub A natin, that is counterclockwise. No? So negative yung M sub BC natin, that is counterclockwise with respect to the member, no, with respect to the span. That is positive with respect to the span, so clockwise with respect to the span. No? So okay. I hope that will be clear to you, no? So and that ends our video, no? For any questions, don't hesitate to comment, no? Or the usual, you message me on my Blackboard or on any of my social media accounts, no? And at the same time, no? For more updates, kindly like and subscribe to this channel. And possible next topics natin, no, will be no, for slope deflection method, no, we are going to pwedeng itry natin mag-solve ng frames naman kasi this is also applicable to frames, no. And for the next method naman that we can use, no, next displacement method that we can use is called the moment distribution method, no. So just watch out for those possible topics that we can do. Okay, So see you next video.